And now we're ready for subtracting fractions. 7/8 take away 3/8. Are they like fractions?
Yes.
Yes, they are. 8 and 8. 7 of them take away 3 of them is 4 of them. 4/8. Is it finished?
No.
We can reduce it. What can we hit 4 and 8 with?
4.
4 into 4 is?
1.
4 into 8 is?
2.
And the answer is 1/2. Was that easy?
Yes.
Everybody say it.
It's so easy.
And we have to say that to encourage ourselves about things that are to come. 6 and 8/9 take away 2 and 5/9. It's very important to remember to do the fractions before you do the whole numbers. 8/9 take away 5/9 is? 3/9. 6 take away 2 is?
4.
4 and 3/9. Is it finished?
No.
Because we have to reduce it. What can we hit 3 and 9 with?
3.
3 into 3 is?
1.
3 into 9 is?
3.
And the answer is 4 and 1/3. Five, 6 take away 1/3. Like or unlike?
Unlike.
Which is the largest bottom number?
6.
Is 6 good for 3?
Yes.
So 6 is our new bottom number. 5/6 remains 5/6. 3 into 6 is?
2.
Times 1 is?
2.
5 take away 2 is?
3.
3/6. Is it finished?
No.
You can reduce it. Hit them both with?
3.
3 into 3 is?
1.
3 into 6 is?
2.
The answer is 1/2. 6 and 4/5 take away 2 and 3/4. Like or unlike?
Unlike.
Which is the biggest bottom number?
5.
Is 5 good for 4?
No.
5 times 1 was no good. Let's try 5 times.
2.
5 times 2 is?
10.
Is 10 good for 4?
No.
5 times 3 is?
15.
Is 15 good for 4?
No.
5 times 4 is?
20.
And 20 is good for 4. 20 is your new bottom number. 5 into 20 goes?
4 times 10.
And 4 times 4 is?
16.
16. 4 into 20 goes?
5.
Times 3?
15.
16 take away 15 is 1/20. And don't forget, 6 take away 2 is 4. The answer is 4 1/20. 4 2/3 take away just 1/3. 2/3 take away 1/3 is 1/3. 4 take away what?
0
Is
4.
nothing too difficult about that. 5 3/5 take away 4. 3/5 take away nothing is
3/5.
still 3/5. 5 take away 4 is
1.
the answer is 1 3/5. 2 take away 1/3. Let's draw a picture. We have 2 pizza pies. What do we need to take away 1/3 of a pizza? What do we have to do? What do we need to have in our hands to take away 1/3 of one of those pizzas?
We have thirds.
And how do we get thirds? We need a knife. You have to cut up one of those pies. You need a knife. Very good. We're going to cut up one of these pies, all right? One of them we will not cut up, but the other one we will take a knife and we will cut it into what kind of pieces?
Thirds.
Thirds. 1/3, 1/3, and 1/3. The reason we did that is because 0 take away 1/3 is can't do. So we have to borrow. We have to cut up one of these 2 pies. And we cut it up into 3/3. Now here we have 2 whole pies. But what has that now become? How many whole pies?
1.
And what else do we have? 3/3. 2 became 1 3/3. And what we say is we cut up 1 pie, we got 1 whole pie left, and 3/3. 1 3/3 is the same as 2 because 3/3 is 1 whole pie that's just been cut into 3 pieces. Now we can subtract. 3/3 take away 1/3 is 2/3. And 1 take away 0 is
1.
the answer is 1 2/3. One take away 7/8. 0 take away 7/8 is? Can't do. We have to borrow from the 1. The 1 becomes a
0.
And for that pie that we cut up, we get what? 8 eighths. The whole pie cut into 8 pieces gives us 8 eighths. And I chose to cut it into eighths rather than sixths or fifths or fourths because the problem told me that the kind of pieces I need to take are eighths. You have to take away 7/8, and now we can do that. 8/8 take away 7/8 is 1/8. And 0 take away 0 is
0.
which we do not have to write. So we have the answer of 1/8. Seven take away 2 and 5/7. 0 take away 5/7.
Can't do.
Can't do. We borrow from the 7. The 7 becomes a,
6.
and for that we get
7/7.
7/7 take away 5/7 is
2/7.
6. Take away 2 is
4.
the answer is 4 and 2/7. Two and 1/3 take away 1 and 2/3. 1/3 take away 2/3. 1 take away 2. The answer is? Can't do. Let's draw a picture. 2 and 1/3. Well, we need some more thirds. We have to cut up one of our pies. We started with 2 and 1/3, but we are going to take one of those pies and cut it into what kind of pieces?
Thirds.
1/3, 1/3, 1/3. Here we had 2 and 1/3. How many whole uncut pies do we have now?
3.
Down here. Just 1. 1 uncut pie. And how many thirds do we have?
4.
We got 3/3 for the one we cut up, plus the one which we already had makes 4. 1 and 4/3. 2 and 1/3 is the same as 1 and 4/3. We cut up one of those pies into 3/3. We have 1 and 1, 2, 3, 4/3 now. 3/3 for the pie we cut up, plus the 1/3 we already had makes 4. 1/3 take away 2/3 can't do. The 2 became a 1. We cut up a pie. We got 3/3 plus the one we already had made 4. 3/3 for the one we cut up plus the one we already had makes 4. And when you do this kind of problem, it's always going to be the bottom number, which tells you what kind of pieces, thirds, plus how many you already had to give you the new top number. 3 plus 1 is 4. Now, 4 take away 2 is?
2.
So we have 2 thirds. And 1 take away 1 is?
0.
And so the answer is just 2 thirds. Here's another one very much like it. 3/8 take away 5/8 can't do. We cut up one of these pies, so we have 4 uncut pies left. For the pie we cut up, we got 8/8 plus the 3 we already had. 8 plus 3 is 11. 11 take away 5 is 6/8. 4 take away 2 is 2 and 6/8. Is it finished?
No.
What can we do?
Reduce it.
We can hit 6 and 8 with
2.
2 into 6 is
3.
2 into 8 is?
4.
The answer is 2 and 3/4. Six and 3/8 take away 2 and 3/4. There's nothing in this problem that you don't already know how to do, but it does make you use everything you know about subtracting fractions. First of all, like or unlike?
Unlike.
Therefore, we have to make them like. Which is the largest bottom number?
8.
Is 8 good for 4?
Yes.
Isn't that nice? Okay. 8 is our new bottom number. 3/8 is still 3/8. 4 into 8 is?
2.
2 times 3 is?
6.
First, you make them like fractions. Then you see if you have to borrow. You cannot tell if you have to borrow until they are like fractions. First, you make them like fractions. We did that. 3 take away 6.
3 can't do.
Can't do. Remember, it's not 6 take away 3, but it's 3 take away 6. Can't do. We have to cut. The 6 becomes a?
5.
We cut up a pie into 8/8 plus the 3 we already had makes 11/8. 11 take away 6 is
5.
5/8. And 5 take away 2 is
3.
3 and 5/8 is the answer. When you are subtracting fractions, if you do everything right, you will never have an improper fraction in your answer. That happens in addition, but it doesn't happen when you subtract if you have done everything right. But you may have a fraction that needs to be reduced. So this last one will be like your final exam for subtracting fractions. 4 and 3/4 take away 2 and 4/5. Like or unlike?
Unlike.
Which is the larger bottom number?
5.
Is 5 good for 4?
No.
5 times 2. 5 times 2 is?
10.
Is 10 good for 4?
No.
5 times 3.
15.
Is 15 good for 4?
No.
5 times 4.
20.
Is 20 good for 4?
Yes.
20 is your new bottom number. 5 into 20 is?
4.
4 times 4 is?
16.
4 into 20 is?
5.
5 times 3 is?
15.
15. Take away 16.
And do.
Can't do. The 4 becomes a?
3.
You cut your pie into 20 20ths plus the 15 you already had. How much is 15 plus 20?
35.
35. 35. Now we have to do 35 take away 16. 5 take away 6.
Can't do.
The 3 becomes a 2, so the 5 can be a 15. 15 take away 6.
9.
2 take away 1.
1.
19 20ths. 3 take away 2 is 1. The answer is 1 and 19 20ths. Was that hard?
No.
You mean it was easy? Everybody say, it's so easy. When we first learned how to multiply, we had a picture that looked like this. We had a line that was 3 units long and a line that was 2 units long. This was 3 and this was 2. And we wanted to find out what 3 times 2 was. We completed these boxes and we found that 3 times 2 was 6. 1, 2, 3, 4, 5, 6. The space or the area inside this rectangle is 6 squares. Now we're going to zoom in on just one of those squares. And we're going to blow it up just a little bit. Now the length of this line here is 1. And this length of this line here is also 1. This is 1 whole pizza pie. But Uncle Dan, it's square. It's not round. Well, Haven't you ever heard of square pan pizza? It's delicious. It has a nice thick dough and all the same goodies on top. So this is a square pan pizza. Now, we would like to cut it. How many pieces did we cut it into?
3.
What is the length of this line right here?
1.
1/3. And this one is 1/3. And this distance is 1/3. 1/3 plus 1/3 plus 1/3 is 3/3. And 3/3 is always equal to 1 whole. So this distance across is 1, but we've divided it into distances of 1/3. The space in here is 1 times 1/3. 1 times 1/3. Well, we've divided our pizza into 3 pieces. If I eat this much, how much of the pizza have I eaten?
1/3.
So therefore, 1 times 1/3 equals 1/3. And we also know that anything multiplied by 1 equals that same thing itself. Now we have another square pizza. This time we're going to divide it in 4 pieces. How long is this distance across the top?
1.
And how long is each of these little distances down the side?
1/4.
1/4. So this time we have this space in there. And what is the area of this space? 1/4 times 1. How much of the pizza have I eaten?
1/4.
1/4. Now, we're going to take this pizza here and pick it up and move it on top of this one so that we've cut it both ways. And we'll draw it again. How long is this distance on top?
1/3.
1/3. And how long is this distance here on the side?
1/4.
1/4. That means if we eat this much, we will be eating a piece that is 1/4 times 1/3. So if we can figure out the answer to that, we really will be multiplying fractions. Well, how many pieces are there in this whole pie? 12. 1, 2, 3 times 1, 2, 3, 4. 12. And how many of them are we eating?
1.
We're eating 1. 1 out of 12, 1/12. Now, when we multiply fractions, we do not always have to make a diagram like this, but I just did it to show you what it looks like if you draw a picture. All we need to know is that when we multiply fractions, we just multiply across the top and multiply across the bottom. 1 times 1 is?
1.
And 4 times 3 is?
12.
It works. It gives us the same answer that we got when we drew our picture. Suppose we'd like to have a little more pizza than that. We would like to have this much times that much. How long is this distance right here?
2/3.
2/3. 1/3 and another third. And how long is this distance right here?
3/4.
3/4. So this time it's 3/4 times 2/3. Well, we are going to be eating all this. How many pieces are there in the whole pizza?
12.
And how many are we going to eat?
6.
1, 2, 3, 4, 5, 6. We are going to eat 6/12 of that pizza. Now let's multiply across and see if we get the same answer that we got from our picture. 3 times 2 is?
6.
4 times 3 is?
12.
Is it finished?
No.
Why not?
We need to reduce it.
Yes, we need to reduce the answer. What can we hit 6 and 12 with?
2.
6.
6.
Well, some say 2 and some say 6, but the best thing to hit it with is the largest one that will work, and that's 6. 6 into 6 is?
1.
And 6 into 12 is?
2.
That means that 3/4 times 2/3 is equal to 1/2. And yes, we have eaten half of this pizza because there's 12 pieces and we ate 6 of them. Two-thirds times 5/8. Let's multiply across. 2 times 5 is?
10.
3 times 8 is?
24.
Is it finished?
No.
Can we reduce it?
Yes.
What shall we hit it with?
2.
2 into 10 is?
5.
2 into 24 is?
12.
And the answer is 5/12. But we have a special trick to make less work for ourselves. Let's look at our original problem, 2/3 times 5/8, and answer this question. Is there a number that will go evenly into something on the top and something on the bottom?
Yes.
What number can go into something on the top and something on the bottom?
2.
And what numbers can it go into?
2 and 8.
We can hit the 2 and the 8 with 2. Let's do it. As I say it, watch what I do. I say 2 into 2 is 1. And 2 into 8 is 4. I cross it out right as I say the number. I have canceled it out. That little trick is called canceling. Now let's multiply across. 1 times 5 is 5. 3 times 4 is
12.
You can see that if we do our canceling here, we will get an answer that is already reduced to lowest terms, and we'll have less work and smaller numbers to work with. We can now skip that step entirely. From now on, every time you see an opportunity to cancel, you should do it. 3/5 times 1/6. Is there a number that will go evenly into something on the top and something on the bottom?
Yes.
What can I hit with what?
3.
I can hit the 3 and the 6 with 3. 3 into 3 is?
1.
3 into 6 is?
2.
Now, when you cross it out, you should always cross it out in the same direction. You can choose to do it this way all the time, or you can choose to do it the other way all the time, but pick the way that you like and always do it the same way within any one problem, otherwise it looks confusing. Let's multiply across. 1 times 1 is?
1.
5 times 2 is?
10.
And you will see that that answer is already in lowest terms. If we hadn't done it that way, we would have had 3 times 1 is 3, and 5 times 6 is 30, 3/30ths, and then we would have had to do the extra work of reducing that to 1/10. This is a much better way. 5/7 times 7/9. Now, I'll ask the question this way. Can you tell me a pair of numbers that we can hit with something?
Yes.
What numbers?
7.
7 and 7. And what can we hit them with?
7.
7 into 7 is 1. 7 into 7 is 1. Now multiply across. 5 times 1 is?
5.
1 times 9 is?
9.
The answer is 5/9. 3/4 times 8/9. Can you tell me a pair of numbers that we can cancel?
Yes.
What numbers?
3 and no, 3. Both of them.
Lots of ideas. Some say 3 and 9. Let's try that. What can I hit the 3 and 9 with?
3.
3 into 3 is?
1.
3 into 9 is?
3.
What else can I do? What's the other pair?
4 and 8.
4 and 8. 4 into 4 is?
1.
4 into 8 is?
2.
Now we'll multiply across. 1 times 2 is?
2.
1 times 3 is?
3.
The answer is 2/3. 1/6 times 8/9. Is there a pair of numbers that we can cancel?
Yes.
Yes, there is, but it's a little bit harder to see it than the ones we've done already. And that's because the 6 will not go evenly into the 8. However, there is a number that will go evenly into both the 6 and the 8. What number can we hit it with?
2.
2. 2 into 6 is?
3.
And 2 into 8 is?
4.
1 times 4 is?
4.
3 times 9 is?
27.
27. The answer is 4/27. 7/15 times 10/21. Is there a pair of numbers that we can cancel?
Yes.
Tell me the pair.
7 and 21 and 15.
Okay, lots of ideas. 7 and 21. What can we hit the 7 and 21 with?
7.
7 into 7 is?
1.
7 into 21 is?
3.
What can we hit the 10 and the 15 with?
5.
5 into 10 is?
2.
5 into 15 is?
3.
1 times 2 is?
2.
3 times 3 is?
9.
The answer is 2/9. 15/16 times 24/25. Can we do anything with the 15 and the 25?
Yes.
What can we hit them with?
5.
5 into 15 is?
3.
5 into 25.
5.
Can we do anything with the 16 and the 24?
Yes.
What can we hit them with?
4.
Well, we can hit them with 4, we can hit them with 2, and we can hit them with 8. Which is the best thing to hit them with?
8.
It's always best to hit it with the largest number. Now suppose we decided to use 4 instead. Let's try 4. 4 into 16 is?
4.
4 into 24 is?
6.
Now let's look. We have a 3 and a 6 on top, a 4 and a 5 on the bottom. Is there another cancel that we can do?
Yes.
Yes, we can hit the 4 and the 6 again. What can we hit them with?
2.
2 into 4 is?
2.
2 into 6 is?
3.
So if the first time you don't cancel with the largest possible number, there might be an opportunity to hit it again a second time. So always be watchful for that. Do every possible cancellation you can do before you multiply across, which we're ready to do now. 3 times 3 is?
9.
2 times 5 is?
10.
The answer is 9/10. Five ninths times 3/7 times 7/10. This time we're going to multiply 3 numbers. Now you can find several different possibilities for things that you can cancel in this problem. And I find that the best one to do first is to see if the same number exists on both top and bottom. Do we have that situation?
Yes.
We have 7 and 7. Let's do them first. We can hit them both with?
7.
Hit them with 7. 7 into 7 is?
1.
And 7 into 7 is?
1.
And we like to have ones, because when you multiply by 1, you get the same thing that you started with. What is another pair of numbers that we can cancel?
5 and 9.
5 and 10. What can we hit them with?
5.
5 into 5 is?
1.
5 into 10 is?
2.
And we like to see those ones. And what's the other pair of numbers that we can cancel?
3 and 9.
Hit them with?
3.
3 into 3 is?
1.
3 into 9 is?
3.
Now we can multiply across. 1 times 1 is?
1.
And that 1 times 1 is? 1. 3 times 1 is?
3.
And that times 2 is?
6.
The answer is 1/6. 3/5 times 5/9 times 3/10 times 2/15. Now we have 4 of them. Let's see how much we can cancel that. Is there any place where we have the same number?
Yes.
The 5 and the 5. 5 into 5 is?
1.
And 5 into 5 is 1. Now, the next kind of possibility that we'll look for is a cancellation that gives us at least one number 1. What's a pair of numbers that will do that? 3 and 9. And I think I'll choose this 3. 3 into 3 is?
1.
And 3 into 9 is?
3.
What's another pair of numbers we can cancel?
2 and 10.
2 and 10. Hit them with what?
2.
2 into 2 is?
1.
2 into 10 is?
5.
And what's another pair of numbers?
3 and 15.
3 and 15. 3 into 3 is?
1.
And 3 into 15 is?
5.
Okay, I think we're ready to multiply across. All we have on top is ones. 1 times 1 is?
1.
Times 1 is?
1.
Times 1 is?
1.
1. That's why we like ones. 1 times 3 is?
3.
Times 5 is?
15.
Times 5 is?
75.
75. 5 times 5 is 25. Carry the 2. 1 times 5 is 5. Plus 2 is 7. This whole thing cancels down and multiplies to 1/75. Eight 25ths times 15 32nds times 4/5 times 5/6. What shall I cancel first?
5 and 5.
5 and 5. 5 into 5 is 1. 5 into 5 is 1. What shall I cancel next?
82.
8 into 32. Now, I have lots of choices. I could cancel the 8 into the 32, Or I could cancel the 4 into the 32. And it doesn't matter which way you do it. There are many roads on this problem, and they all lead to the same place. Just as long as you do everything right, you have choices. Let's do the 8 and the 32. 8 into 8 is?
1.
8 into 32 is?
4.
What's another pair of numbers that we can cancel?
15 and 25.
15 and 25. I can hit them both with?
5.
5 into 15 is?
3.
5 into 25 is?
5.
Are there any more numbers that I can cancel?
Yes.
Yes, there are. There are some that I can hit again. What is a pair of numbers that I can cancel?
4 and 6. 4.
I could do 4 and 6. I could do 4 and 4. I could do 3 and 6. I have all those possibilities, but I'll do the first one I heard about, 4 and 6. What can I cancel 4 and 6 with?
2.
2 into 4 is?
2.
And 2 into 6 is?
3.
Am I finished canceling?
No.
What shall I do next?
2 and 4.
2 and 4. 2 into 2 is?
1.
2 into 4 is?
2.
Any more?
Yes.
3 and 3. 3 into 3 is 1. 3 into 3 is 1. And all I have on top is 1s. 1 times 1 is?
1.
Times 1 is?
1.
Times 1 is?
1.
5 times 2 is?
10.
Times 1 is?
10.
Times 1 is?
10.
That whole thing cancels down and multiplies across to just 1/10. Imagine if we hadn't canceled and we decided to multiply across and then reduce it. We'd have to do 8 times 15 and get an answer, multiply that times 4 and get an answer, multiply that times 5 and get an answer. It would be some big number. And the same on the bottom. We'd have to multiply 25 times 32 just to begin with. Then get that answer and multiply it times 5 and then times 6. So canceling really saves time and makes your work easier. Now, here's an interesting fraction. What would you tell me about that fraction?
It's improper.
It's improper because the top number is not smaller than the bottom number. Well, we always divide the bottom into the top. Let's do that. How many times does 1 fit into 5?
5.
5 times. 5 times 1 is 5, with nothing left over. So 5 over 1 is the same thing as 5. How about 7 over 1? That's the same thing as?
7.
How about 20 over 1?
120.
37 over 1.
37.
Anything over 1 is the same as that number. 5 over 1 is 5. Now that's going to become an important little tool. The next problem is 1/8 times 32. Well, you say, how can I multiply across? I don't know what this 32 is. It's not a fraction. Is it on the top Is it on the bottom? I don't know. But we just learned that 5 over 1 is 5, and 32 over 1 is 32. So to remind ourselves that this is a top number, when we have a whole number in a multiplication problem, we just put it over 1, because 32 is the same thing as 32 over 1. Now we can clearly see that the 32 is a top number. Is there anything we can cancel?
Yes.
The 8 and the 32. And what can we hit them with?
8.
8. 8 into 8 is?
1.
And 8 into 32 is?
4.
Now we'll multiply across. 1 times 4 is?
4.
1 times 1 is?
1.
And our answer is 4 over 1. Do we like that as an answer?
No.
Why not?
It's improper.
Yes, it's not proper. 4 over 1 is the same thing as just plain whole number 4. And that's our answer, and we write it large to fill up the whole space. The answer is 4. "64 times 5/8. What shall I do?" What do I do with the 64? Yes, you can say write a 1 under it, or you can say put it over 1, which is the way we usually say it. We'll put it over 1. Now can we cancel?
Yes.
8 into 8 is?
1.
And 8 into 64 is?
8.
Then we can multiply across. 8 times 5 is?
40.
1 times 1 is?
1.
And 40 over 1 is the same thing as?
40.
40. And that is our answer. "1/4 of 24 equals what?" But you say, "Uncle Dan, what does of mean? We never saw of before. You told us how to add and subtract and multiply, and you've taught us some things before about divide, but you never taught us how to of." How do you of? Well, from now on and for everything that you ever see in math, of means times. Of is the same thing as times. So we'll just change that to times. Of means times. Anytime you see of, or anytime you have a story problem that has of in it, it probably is going to mean times. Well, what shall we do with the 24?
Put it over 1.
Put it over 1. Can we cancel?
Yes.
4 into 4 is 1, and 4 into 24 is?
6.
1 times 6 is?
6.
1 times 1 is?
1.
And 6 over 1 is?
6.
Now let's see if that sounds right. 1/4 of 24 is 6. Does that sound right?
Yes.
Yes, it does. Because if we have 4 of those 6s, we will get 24 back again. 1/4 of 24 is 6. Two-thirds of 27 equals what? What's the first thing I do?
Put 27 over 1.
Well, we can do that. And then what's the next thing I do?
Cancel.
How about of? The first thing that I would do is make of into times. Then I would put the 27 over the 1. Can I cancel?
Yes.
What 2 numbers can I cancel?
3 and 27.
And what can I hit them with?
3.
3 into 3 is?
1.
And 3 into 27 is?
9.
Now we'll multiply across. 2 times 9 is?
18.
1 times 1 is?
1.
And 18 over 1 is the same thing as?
18.
And it sounds good to me that 2/3 of 27 should be something like 18. Two and 1/3. What kind of a number is that? That is a mixed number because it has a whole number and a fraction. Now we have already learned how to take an improper fraction and change it into a mixed number. Now we're going to learn how to take a mixed number and turn it back into an improper fraction. 2 and 1/3. 2 whole pies and 1/3 of another pie. We want to find out how many thirds that would be if we cut up these 2 pies into thirds. 1/3, 1/3, 1/3. How many pieces 1/3 do we have? 1, 2, 3, 4, 5, 6, 7. 7/3. But we don't have to count them up one by one. We have 2 pies, each of which has 3. 3 taken 2 times. 3 times 2 is
6.
plus the 1 is
7.
And that's exactly the way we do it when we don't have a diagram. We just look at the mixed number and we say 3 times 2 is
6.
plus 1 is
7.
so 2 and 1/3 is the same thing as 7/3. 4 and 2/3. We say 3 times 4 is
12.
plus 2,
14.
14. And what kind of pieces are they? 14 what?
Thirds.
14 thirds. And that's how to change a mixed number into an improper fraction. Now, before we learned that if we had 14 thirds, we would divide the 3 into the 14. And we'll see that if we do that, 3 into 14 goes how many times?
4.
4. 4 times 3 is?
12.
With how many left over?
2.
2. 2 what?
Thirds.
2 thirds. So 14 thirds is the same as 4 and 2 thirds. Now the reason we learned that is so that we could do a multiplication problem that has a mixed number in it. 4 and 2 thirds times 6 sevenths. We cannot multiply it in the form that it is now as a mixed number. So we have to change it to an improper fraction. We have to rewrite the problem with that change. Let's change it. 3 times 4 is?
12.
Plus 2 is?
14.
14 thirds, and the 6 sevenths stays the same. Now we have finished with this part, and all we have to do is work with this part. This is the part that we have to solve. Is there any canceling we can do there?
Yes.
What pair of numbers can we cancel?
6 and 3.
3 and 6 and 14 and 7.
All right, let's pick one. 7 and 14. 7 into 7 is?
1.
7 into 14 is?
2.
What can I hit the 3 and 6 with?
3.
3 into 3 is?
1.
3 into 6 is?
2.
Multiply across. 2 times 2 is?
4.
1 times 1 is?
1.
And 4 over 1 is the same thing as?
4.
4. The answer is 4. Four fifths times 7 and 1 halves. The 4 fifths can stay the same. The 7 and 1 half is a mixed number. We have to make it an improper fraction. 2 times 7 is?
14.
Plus 1 is?
15.
15 halves. Can we cancel the 4 and the 2?
Yes.
What can we hit them with?
2.
2 into 2 is?
4. 1.
1. And 2 into 4 is?
2.
Can we cancel the 5 and the 15?
Yes.
With what number?
5.
5 into 5 is?
1.
5 into 15 is?
3.
Multiply across. 2 times 3 is?
6.
1 times 1 is?
1.
The answer is?
6.
Just plain whole number 6. Three and 1/3 times 3 and 3/5. This time, both of them are mixed numbers. 3 times 3 is?
9.
Plus 1 is?
10.
10/3. 5 times 3 is?
15.
Plus 3?
18.
18/5. Can we cancel the 3 and the 18?
Yes.
What can we hit them with?
6.
Well, we can hit them with 3. We will see a 6. 3 into 3 is?
1.
3 into 18 is?
6.
There's our 6. What can we hit the 5 and the 10 with?
5.
5 into 5 is?
1.
5 into 10 is?
2.
2 times 6 is?
12.
1 times 1 is?
1.
12 over 1 is the same thing as?
12.
12. Three and 2/3 times 3 and 3/4. 3 times 3 is?
9.
Plus 2 is?
11.
11/3. 4 times 3 is?
12.
Plus 3 is?
15.
15/4. Can we cancel the 3 and the 15?
Yes.
What can we hit them with?
3.
3 into 3 is?
1.
3 into 15 is?
5.
Can we cancel the 4 and the 11?
No.
No, we cannot. We have to multiply across. 11 times 5 is?
55.
55. Now, if you don't know your 11's table, you can just say 1 times 5 is 5, and 1 times 5 is 5. But the 11's table is very easy because it's 1, 1, 2, 2, 3, 3, 44, 55, 66, 77, 88, 99, and then it changes a little bit. 55. 1 times 4 is? 4. Our answer is 55/4. Is it finished?
No.
Why not?
It's improper.
It's an improper fraction. We have to divide bottom into top. 4 into 55. 4 into 5 goes?
1.
1 times 4 is?
4.
5 take away 4 is?
1.
Bring down the
5.
4 into 15 is?
3.
Because 3 times 4 is?
12.
5 take away 2 is?
3.
3 what?
3/4.
3/4. 13 and 3/4. 13 and 3/4. We started this problem with 2 mixed numbers. We had to change them to improper fractions so that we could multiply them. Then we got an answer that was an improper fraction, and we had to change that back into a mixed number. And our final answer was this mixed number, 13 and 3/4. We're going to learn how to divide fractions. And if you know how to multiply fractions, you almost already know how to divide. 4/5 divided by 2/9. When you do a division problem in fractions, all you have to do is 2 things. You keep the 4/5. You change the division to multiplication, and you take the second number and flip it upside down. 2/9 becomes 9/2. You've written the problem over again, you've changed it to multiplication, and you've switched the second number from 2/9 to 9/2. You've flipped it upside down. Now you can just multiply. Can I cancel the 2 and the 4?
Yes.
Hit them with what?
2.
2 into 2 is?
1.
2 into 4 is?
2.
Can I cancel the 5 and the 9?
No.
No, I cannot. 2 times 9 is?
18.
5 times 1 is?
5.
18/5. Is it finished?
No.
Why?
It's improper.
It's an improper fraction. We have to divide the 5 into the 18. 5 into 18 goes how many times?
3.
3 times 5 is?
15.
8. Take away 5 is?
3.
3 what?
6.
3/5. 3 and 3/5 is the answer. Seven and 4/5. 13/20. How do I read this problem? I say 7 and 4/5 divided by 13/20. The second number is the one that you are dividing by. The number that you take and flip upside down is the one that you are dividing by. And it's very important that you flip the right number. If you do the wrong number, you'll get the wrong answer. 7 and 4/5 divided by 13/20. Well, I have a mixed number. I have to make it an improper fraction. 5 times 7 is?
35.
Plus 4?
39.
39/5. Change it to times. Take the 13/20 and flip it to 20/13. Can I cancel the 5 and the 20?
Yes.
What can I hit them with?
5.
5 into 5 is?
1.
5 into 20 is?
4.
Can I cancel the 13 and the 39?
Yes.
Yes, I can. Let's try 13 into 39 and see if it goes evenly. That's the kind of cancellation that it's really easy to miss because it's not a number that you're familiar with and it's not on your times table. How many 13s do you think will go into 39?
3.
Let's try 3. 3 times 3 is 9. 1 times 3 is 3. Yes, indeed, it works. So, 13 into 13 goes? Once. And 13 into 39 is? 3. Multiply across. 3 times 4 is?
12.
1 times 1 is?
1.
And 12 over 1 is the same thing as 12. The answer is 12. Four and 3/8 divided by 6 and 1/4. They are both mixed numbers. We'll have to change them both to improper fractions. 8 times 4 is,
32.
plus 3,
35.
35 eighths. Change it to times. 4 times 6 is,
24.
plus 1 is,
25.
you have therefore 25 fourths. You have to take the 25 fourths and flip it to 4 25ths. 4 25ths. Can we cancel the 4 and the 8?
Yes.
What can we hit them with?
4.
4 into 4 is?
1.
4 into 8 is?
2.
Can we cancel the 25 and the 35?
Yes.
What can we hit them with?
5.
5 into 25 is?
5.
5 into 35 is?
7.
7. Multiply across. 7 times 1 is?
7.
2 times 5 is?
10.
7 tenths. Is it finished?
Yes.
Yes, it is finished. It's not an improper fraction. It's already reduced to lowest terms. It's already done. So now you have learned how to add, subtract, multiply, and divide fractions. Now we're going to do some story problems with fractions. Now, many of the story problems that you might find that have fractions in them are just the same as any other story problems that you might do that have whole numbers in them, and you have to do the same kind of thinking and decide whether to multiply or divide or add or subtract. You have to get a plan of attack and think it through. And the only thing that's different are the numbers, that instead of 5, maybe it says 5.5. Instead of 3, maybe it says 3 2/3. But there are some story problems that are really unique and have to do just with fractions. So we're going to do a couple of problems like that, and then one more problem that I think is kind of interesting. So, first problem. Once upon a time, there were 36 teens at the fellowship. 4/9 of them were girls. What fractional part of the group was boys? Well, the whole group is one whole group, and 4/9 of them were girls. 4/9. What can I do with those two numbers to find out what fractional part, what part of the group was boys?
Subtract.
Subtract. Because if 4/9 of them were girls, then all the rest of them were boys. Well, we have one whole group. Well, if we try and subtract, 0 take away 4/9, can't do. So we have to borrow. The 1 becomes a 0 so that we can have 9/9. And maybe that's an even clearer way to see it. The whole group was 9/9 of itself. 4/9 of the group were girls. What part of the group was boys. 9/9 was the whole group. Take away the 4/9. 9/9 take away 4/9 is 5/9. 5/9 of the group was boys, because 4/9 of the group was girls. The next question, it says, how many girls were there? Well, we know there were 36 teens, and 4/9 of them were girls. 4/9 of the 36 were girls. What's the first thing I do when I see 4/9 of 36? What does of mean?
Multiply.
Yes, of means times. And what do I do with the 36?
Put it over the 1.
Put it over 1. Can I cancel the 9 and the 36?
Yes.
What do I hit it with?
9.
9 into 9 is?
1.
9 into 36 is?
4.
4 times 4 is?
16.
1 times 1 is?
1.
And 16 over 1 is the same thing as?
16.
16. 16 what?
Girls.
16 girls. You remember there were 36 in the group. 4/9 of them were girls, and 4/9 of 36 is 16. Now, the last part of the question. How many boys were there? Well, there are 2 ways to do this. How many teens in the whole group?
36.
36 total. How many were girls?
16.
What do I do with those 2 numbers?
Take away.
Subtract.
Subtract. 6 take away 6 is?
0.
3 take away 1 is?
2.
If the total was 36 and 16 were girls, then 20 were boys. But I said there's another way to do this. When we did the first question, we found out that the answer to what fractional part of the group was boys was 5/9. That means 5/9 of the 36 are going to be boys. What do we do with the of? Times. What do we do with the 36?
Put it over 1.
And we cancel the 9 and 36. We hit them with
9.
9 into 9 is?
1.
9 into 36 is?
4.
5 times 4 is?
20.
1 times 1 is?
1.
And 20 over 1 is 20. We got that same answer both ways. And this problem really is uniquely a fraction problem because it talks about what fractional part, and 4/9 of them were girls. Here's another story problem. And we're gonna roll. There were 48 children that went ice skating. 2/3 of them were girls. 3/8 of the girls wore red sweaters. What fractional part of the group was girls with red sweaters? 2/3 of them were girls. 3/8 of the girls wore red sweaters. 3/8 of the 2/3. 3/8 of the 2/3. This will tell us what fractional part of the group were girls with red sweaters. 2/3 were girls. 3/8 of the 2/3 had red sweaters. Well, of means what?
Multiply.
Multiply. Can I cancel the 3 and the 3?
Yes.
We get 1s. Can I cancel the 2 and the 8?
Yes.
And hit them with what?
2.
2 into 2 goes.
1.
2 into 8 goes.
4.
1 times 1 is.
1.
4 times 1 is.
4.
That means 1/4 of the group was red sweater girls. Girls with red sweaters. Now we have another question. The second part says, how many of the children were girls with red sweaters? How many of the 48 were girls with red sweaters? Well, we've already answered the question of what fractional part of the group was girls with red sweaters. We found out that 1/4 of them. So we know that 1/4 of the 48 will give us the number of girls that had red sweaters. Of means what?
Multiply.
Of means multiply. The 48 goes over
The 1.
1. Can I cancel 4 and 48?
Yes.
Let's see if 4 will divide evenly into 48. Yes, it does. 4 into 4 goes once. 4 into 8 goes twice. 12. 4 into 4 goes once. And 4 into 48 goes
12.
12. 1 times 12 is,
12.
and 1 times 1 is
1.
1. And 12 over 1 is
12.
12. There were 12 red sweater girls. How many girls were there with blue sweaters?
48 took away 12.
I fooled you. You can't tell how many have blue sweaters, how many have green sweaters, or how many have no sweaters at all. All you can tell is how many were red sweater girls. Now we're going to do one more story problem with fractions. Yes, here is our final story problem with fractions. Uncle John wanted to put tiles on a floor. Each tile measures 2/3 by 3/4. How many tiles does he need for a floor that is 24 by 24? Well, we have a diagram to help us. The whole floor is 24 by 24. It's a square. 24 by 24. Each tile is 3/4 by 2/3. We need to find out how many tiles we need to cover the whole floor. Well, how are we going to find out how many we need to go across the top? Each one is 3/4. And the whole distance is 24. What do we do with those two numbers, 24 and 3/4? We want to find out how many 3/4 there are in 24. What do we do with those two numbers? Do we add, subtract, multiply, or divide? How many 3/4 are there in? Well, we don't have too many answers because people aren't so sure what to do. And that's because the number is a fraction. What if this number wasn't 3/4? What if this number was just 3? And I said, how many 3s are there in 24? Would you know what to do? Yes. What would you do with 3 and 24? How many 3s in 24? Do you add, subtract, multiply, or divide?
Divide.
Divide. So sometimes when you have a fraction word problem and it's not clear right away what you want to do, take one of those numbers that's a fraction and just replace it in your mind with a whole number. And then you might find it easier to figure out what to do. So, if it were 3, we would do 24 divided by 3 to find out how many 3/4 there are in 24. If it were 3, if it were 3/4, which it is, we have to divide 24 by 3/4. 24 divided by 3/4 is what? What do I do with the 24?
Put it over 1.
Put it over 1. Now it's a division problem. We have to rewrite it. The division becomes times. What do I do with the 3/4?
Flip it over.
Flip it over, and it becomes 4/3. Can I cancel the 3 and the 24?
Yes.
3 into 3 goes.
1.
3 into 24 goes.
8.
Now I can multiply across. 8 times 4 is
32.
32. And 1 times 1 is 1. 32 over 1 is the same thing as
32.
32. So let's look at our diagram again. If I have a tile that is 3/4 long, I could fit 32 of them in this distance that has 24. 32 of those tiles. You say, Uncle Dan, it doesn't look like you could fit 32 of these in that little space. Well, that's because I did not draw this to exact scale. Sometimes when you make a diagram, you have to take part of it and make it a little bit larger than it might normally be so you can see it. If I made it exact scale, either I would have a very, very tiny little tile that you could hardly see, or I'd have a very, very big room, a very big square. So you'll have to bear with me. But if this distance is 3/4, we can fit 32 of them across the top. Well, how many can we fit down the side? How many 2/3 are there in a distance of 24? What do I do with those two numbers, 24 and 2/3? Divide. Again, I have to divide to find out how many 2/3 are in 24. I put the 24 over 1. I change it to times, and the 2/3 becomes 3/2. Can I cancel the 2 and the 24?
Yes.
2 into 2 is 1. 2 into 24 is 12. And 12 times 3 is what?
36.
12 times 3 is 36. 36 over 1 is the same thing as 36. So I have 36 of those tiles down the side. Well, if I have 32 across the top and 36 down the side, what do I do with those two numbers to find out how many tiles in all?
Multiply.
Yes, I do. I multiply 32 times 36. 2 times 6 is 12. Put down the 2, carry the 1. 3 times 6 is 18, plus 1 is 19. 2 times 3 is 6. 3 times 3 is 9. We add those up. Sometimes we like to put the 0 there. Sometimes we like to put in the boxes just to make sure we don't make a mistake. 2 plus 0 is
2.
9 plus 6 is
15.
carry the 1. 1 plus 1 is
2.
plus 9,
11.
11. 1,152 tiles are needed for this floor. 1,152 tiles. Now there's another way to do this problem. And if you can do it both ways, then you're really an expert. Let's see how it's done. Let's look at our diagram again. We see that each little tile is 3/4 by 2/3. 3/4 times 2/3. If we multiply those two numbers, we'll be able to find out what the area or the space inside one little tile is. Let's do that. 2/3 times 3/4. Can we cancel the 3s?
Yes.
Yes, we can. They go right down to 1s. Can we cancel the 2 and the 4?
Yes.
Okay, 2 into 2 is?
1,
2 into 4 is?
2,
1 times 1 is?
1,
And 1 times 2 is?
2.
2. So the area, the space included in one of those little tiles is 1/2. Let's look at our diagram again. The space of one little tile in here is 1/2, because 3/4 times 2/3 is 1/2. What is the space included in our entire room, which is 24 by 24? What do I do with those two numbers, 24 and 24? What do I do with them?
Multiply.
Multiply. 4 times 4 is?
16.
Put down the 6, carry the 1. 2 times 4 is?
8.
Plus 1 is?
9.
9. 4 times 2 is?
8.
2 times 2 is?
4.
6 plus 0 is?
6.
9 plus 8 is?
17.
Carry the 1. 1 plus 4 is?
5.
576 is the area or the space inside the whole room, which is 24 by 24. How many little tiles, 1/2 by 1/2, can I fit in the big space of 576? How many 1/2s are there in 576? What do I do with those two numbers, 576 and 1/2?
Divide.
Divide, because is there any canceling we can do? No. We have to multiply across. 576 times 2. 6 times 2 is?
12.
Put down the 2, carry the 1. 7 times 2 is?
14.
Plus the 1 is?
15.
Carry the 1. 5 times 2 is?
10.
Plus 1 is?
11.
We multiply across the top, and we got 1152. We multiply across the bottom. 1 times 1 is? 1. And 1152 over 1 is the same thing as 1152. 1152, the same answer that we got the other way. So, now you've done some word problems with fractions, and as I said, most of them will just be problems with numbers that are fractions, but the process is the same as it would be if they were just whole numbers. And that finishes everything we're going to do with fractions, so get ready for decimals.
Golden Age Productions, Golden Age Productions, standing in the gap of your educational needs.